Hi guys. Hello there. This is Tanner Tech. And today we're going to be doing a cool video regarding Xenon flash tubes. So, let's get started. How many people are on? Wow, I have 1 like and 0 viewers. 4 viewers. First, nice. Well, let's fire up these lights so we can get going. Second, wow, you guys are indeed first and second, but now we have a third. Wow. Well, here we have our Xenon flash tube that we're going to be doing it with. Oh, you tried to make a lightning detector and it didn't work? Well, anyway, in this video we're going to be doing a Xenon flash tube to see if it works. It's crazy, I already have 12 people. I only started this live stream like 2 seconds ago. This is the lightning detector that I made. Sorry it didn't work for you. Maybe a comment after this live stream is done and I'll help you out making your lightning detector work. Alright, so this is my Xenon flash tube, and today we're going to be seeing if we can get it to work. So I got this flash tube at a place for like 50 cents. So at the electronics warehouse, which is where I also got like all these resistors, and I got a bunch of cool things like this, a little AC voltmeter. At this electronics warehouse store, I got this cool flash tube. And I wanted to make this flash tube work, but I haven't really gotten the chance to actually do that yet. And so today we're going to see if we can make that work. So we got the flash tube and we've got some Xenon inside it, and hopefully I have all the electronics to make it light up. So, anyway, this is my new camera that I got. This thing is pretty cool. I'm going to be trying to use this to capture the extremely bright flash from the flash tube, because you probably won't be able to see it because it's so quick from the live stream. But anyway, let's get this going. How's it going, someone asked? Pretty good, pretty good. Good lens? Yeah, this thing does have a pretty good lens. Check it out. That can zoom super far. Like, check that out. Yeah, well anyway. Enough of that. Let's get started. So, let's start off with the basics of a flash tube and how they work. And I'll show you some smaller flash tubes that I have. So if we take a look up here, you can see all the flash tubes that I have in my light bulbs bin. Oh, hopefully I have some flash tubes. Oh yeah, I've got this little guy. This little guy is pretty cool. This is a flash tube from a little camera. Just a tiny flash tube. I think over here I have another flash tube. Hello, Fanatical. I think I have a flash tube over here inside my little bin. I know it's in here somewhere. That's the driver circuit for it. If I can't find this flash tube, that wouldn't be good. That's not good. This bin is full of... Oh, there it is. So, I have a few different levels of flash tubes over here. I've got a baby flash tube. I've got a big flash tube, slightly bigger. And I've got a massive flash tube. So I've got those 3 levels of Xenon flash tubes. We're going to try and get these things to activate. So for that we're going to need capacitor banks. So over here I have a capacitor bank. This thing is pretty cool. This is able to give a lot of power. And it has, I forgot how many capacitors are in here. I made a video about it, but this thing has at least maybe 10,000 microfarads at 450 volts. So this capacitor bank is pretty cool. But will it be able to run this giant tube? That's the question. Now we're also getting something to set this off. and we're going to need to go get a high voltage power supply. So we're gonna cruise over here inside my messy closet. I got a few tube radios that I've been working on for a year that I haven't really gotten time to work on. So the Tanotech high voltage power supply. Here it is. This is what we're gonna use to trigger the tubes. I mean, you can build a trigger circuit, but that's too complicated. Thanks you guys for watching. Anyway, we'll hook up the flash trigger circuit and let's see how well this works for now. This will be how we trigger our flashes. Oh, cool. Oh, there it is. Check it out. Well, anyway, that's my trigger circuit for this Xenon flash tube. Looks a little bit like this. Here, let's see if we can get a good view. And this trigger circuit is going to be what's going to trigger the tubes. So, first off, let me explain a little bit about how tubes work. That's important. So, you've got a Xenon tube, and a Xenon tube is pretty basic. You have an evacuated glass cylinder, and these cylinders can be in various different places. And this glass cylinder has been completely evacuated of air, so there's a vacuum inside. But then some xenon has been let inside, so there is a very low pressure xenon gas. And there's an electrode at each end. Now, what happens is, in smaller xenon tubes like this one and this one, typically you have a capacitor right here, an electrolytic capacitor of about 400 volts, and anywhere between maybe 50 and 200 microfarads. Now, the more microfarads you have, the longer the flash will stay on, and the hotter it will get. But anyway, what happens is this charge is stored in the capacitor by some other circuit that boosts voltage up to 400 volts. And that charge is put across the capacitor, across the xenon flash tube. Now, initially, with just these 400 volts across, that's not enough voltage to break down the xenon inside, so that way a current flows across. Essentially, there's nothing here. It's an insulator. But something needs to happen in order to make this tube conduct. And that is where this high voltage power supply comes in. So when there's no high voltage across this, everything's stopped. The gas is non-ionized. But then if you have a high voltage power supply, like this flyback transformer power supply that I built in a previous video, then what will happen is this high voltage power supply, even if it's touching just the outside of the glass, like there's no physical connection to the inside, and you've got another high voltage connection to one of the other points, then what will happen is this high voltage will ionize a little bit of the gas inside the xenon flash tube. And as soon as this gas ionizes, then it'll cause an extremely large current to flow for just a very small amount of time from the capacitor through this xenon tube and back into the capacitor. It'll discharge the capacitor extremely quickly. So that's the basics about how this works. If you look at this xenon tube, you can see, there we go. If you look at this xenon tube, you can see how we have the end, and this is like where the connection goes on top of the glass. Then we have these two ends, and these two ends go to electrodes inside the glass. Same with this one. The electrode on the outside of the glass isn't there at the moment, but the electrodes are on the ends. And in this gigantic tube, you can see that you have this little line of wire going around each little ring inside the tube. And that little wire is what is able to make it ionize the gas inside. And then you have the huge electrode with that extremely thick wire going up to the top, and you've got another thick electrode on the bottom. But I just think the glass work inside this tube is amazing looking. If it'll ever focus. Yeah, the glass work in there is just amazing. Anyway, let's get it to work. First off, I'm going to show you some small tubes, and then I'll show you some big tubes in action. Then we'll try if we can to make the gigantic tube work. That's the point of this video, right? So we've got the capacitor bank, and hopefully I have some alligator clips left. I swear, I'm almost out of these things. No, I've been running short on alligator clips for a while now. I used to have like 50 alligator clips in here, but they all disappeared. It's really annoying. I have no idea where they all went. So, gotta find some alligator clips somewhere. Hold up. Alligator clips. Oh, there's some in this jar up here. This jar has some cool stuff in it, including alligator clips. That can probably be used for high voltage. There we go. I bought this whole can at a garage sale. Some old dude. It's real not easy to grab this stuff sometimes. There we go. There's some alligator clips for me. So we're going to connect this tube up here. Now I hope we're going to charge it up and then discharge it with the high voltage power supply. So as you can see, I'm just going to simply connect this up. Not good enough. Perfect. I got the tube connected. And now we just got to connect it to the high voltage power supply. I will use big alligator clip wire. Hey, for another one. To connect this. And we're going to use this here. We can connect that over here. There we go. That is the setup for one tube. Now we'll see if we can trigger this. So first off, let me charge up my capacitor bank. And this capacitor bank, when it's fully charged, is about 400 volts. And we'll see what's going to happen. Hit this thing to 12.6 volts. As you can hear, you get the perfect sound of it charging. And so as soon as this is charged, the current will flow, and I turn on this. We should see this tube light up, and it should look pretty cool. So right now I've got about 400 volts across this tube, and it should light up. Now I want to be able to show you guys this thing and what it does. So I really hope this doesn't go boom. I mean, if it does, that would be kind of cool. But I'm going to use this camera and see if I can set it up so that way I can take maybe a slow motion video of this thing going off so I can show you guys. I just got to know how to set this up. Let's see. Hopefully I don't screw up my camera doing this. But there's a slow motion video mode. Actually, first let me set my white balance. Perfect. You know what? Here. You're over. You know, that's why I'm trying to use the camera, because I have a feeling I am overcharging that tiny tube. I have a feeling that it's going to blow. Hold up, my dudes. Okay. We're going to use this camera set on top of this thing. Oh no. Sometimes life is tricky. That camera's not tall enough. Yeah, I think it's probably going to be too much for that tube too. see, will this boost it up? Nope. It needs to be boosted taller. This will boost it up taller. Okay, so I've got my camera here to record the slow-mo of what happens. Send you a sandwich? Okay, and then I'll light this off. First, let me increase the frame rate. Set it to manual focus. Okay, hopefully this should work pretty well. Let me fire this small tube off. I think I've got my camera videoing. Oof, that was a bright one. You see that? You guys see that bright flash? That blinded me. Alright, let's feel how hot that tube is. Ah, that tube's hot. See, if you look at the level is almost down all the way. But the tube went off completely with that high voltage and that discharge. Let me show you that one more time. And this time I'm gonna... Yeah, actually, let's look at the slow motion output from the camera. Yeah, less than a frame. Well, let me show you if I can get the frame on here. If I can get the stupid autofocus on YouTube to work. Why is the exposure being wonky? See, this is why I hate sometimes YouTube Live is annoying. Okay, let's see this. Okay. Hopefully this should work pretty well. Let me fire this small tube off. I'll upload this video probably separately. Oh. Oh, no, it just did something. Okay. No, the tube's still alive. Let me fire this small tube off. I think I've got my camera videoing. Okay, now we can go frame by frame. Oh, look at that, look at that. Check out that bright flash. So that was one frame before, and then bright flash, and then frame after. So that one frame is an extremely small bit of time, but that was pretty blinding. Now, we didn't get the tube to explode, but I think we can if we let this charge up longer. I think we can get this tube to blow. So let's try this again. Yeah, I agree. I want that little tiny tube to blow up. I mean, it's going to be almost impossible to blow up the big tube. But I think we can blow up the tiny one. Let me set up the camera again. And, you know what? I'm going to put my camera in slow motion this time. I can set it to 240 frames per second. So if we go to menu set, we can go up to video, and we can go to high-speed video right here. See that? High-speed video. You know what? This exposure is being really stupid. And then we can set it to 240 FPS. So that'll be a low-quality video, but it'll be high frames per second. Alright, here we go. I've got high-speed video on. We're going to charge up this tube, and we're going to see if we can light her off again. And finally, we'll get to the bigger tubes, too. We just got to wait for that little thing to finish starting up. It always takes a little bit. If you look at the thing over there, you can see it's charging at like 0.8 amps. We'll zoom in here real quick so you can see this. So that's the tube. Oh, you're probably right. Oh yeah, if I had a Phantom, that would be cool. Let's see how many frames it takes running this thing. Oh, this thing is charged for sure. Alright. Okay, we're running at 240 frames per second. Let's get this to work. Okay. I'm charging it up again. Well, this thing is not zooming out correctly. Alright, this is charging up again. We're going to try and... Ah! Whew! Did you just see that? I exploded the tube. The tube vaporized. Oh, I didn't get that one on high-speed video either. Dang it. I didn't turn on the camera or think to. Check that out. Look at the tube completely vaporized. Oh my gosh. That is insane. That little tube could not handle that voltage. Look at that. The tube just vaporized itself. Check that out. Let's see if we can watch the high-speed video on the high-speed camera. Oh, look, you can even see the flicker of the AC. Okay, here we go. Let's hope this is a cool video. What? Nothing happened. This is trash. Just a second. This is a 1 minute long video. I'm not, and since it's slow motion, yeah, that tube got ripped. Ah, this camera's annoying. Yeah, there's a vid somewhere here, but it's not working properly. Oh crap, did you see that? Wait. Holy crap, look at that picture. Here, this looks cool. Okay, you have to be able to see this right now. This is cool. Oh my gosh. Holy crap, this is cool. Yeah, this is an awesome video. Look at this. Look at that picture right there. Here, let me turn off the light. See that picture right there? Here, maybe that'll work better. Okay, I'll upload this later. I'll upload this later today. Look at that. Yeah, this would make cool channel art. I'm going to try this again. We're going to try and blow up another tube. I think I got one to blow up. Look at that. That stays glowing for a long time. Okay, that's an awesome video. This is the reason I have a cool camera like this, so I can have cool videos. Alright. Okay, we're going to try that again. We're going to see if we can blow up any more Xenon tubes. I really hope I have another Xenon tube to blow up. If I don't, well then, that's not good. Okay, I think I have a Xenon tube over here in this bag. If I don't have a Xenon tube, then yeah, we'll have to move on with the video. If we do have a Xenon tube, we'll still move on with the video, but in a different way. Oh yeah, here we go. Here we go. Check that bad boy out. This tube will look prime. Let's connect this one up. First and always want to make sure your capacitor bank is discharged. If your capacitor bank is not discharged, you're going to die. First and foremost. First and foremost. Okay, just a second. We're going to be using one of these babies. You know, this video started with me actually trying to teach you guys how to do something, but then it just ended up with this. Just ended up with blowing stuff up. That's how it always ends. Alright, so we got the tube in place. Let's just hook up the negative of this to this somewhere. This whole thing's going to be charged, so I don't want to touch that. This whole thing can go to the negative. Negative will go here. Alright, cool. Alright, we're going to see if we can blow up this Xenon tube. We're going to catch another one on video. This high-speed video stuff is cool looking. Okay, got another 240 FPS video. This is going to be VGA, but 240 FPS. Oh, we gotta turn on the light again. There we go. I'm gonna see if I can boost up this camera just a little bit. I'll use this thing. There we go. Makes it take up more of a frame. Okay. As you can see, I have the camera all ready to record. And let's charge up the capacitor bank. Let's see if we can get it to blow up again. Hopefully. Hopefully. Maybe this time I should wear safety goggles. That may be an actually good idea. Just a second. I'll be right back with safety goggles while that thing charges up. Safety first, guys. Safety is the #1 priority, especially when you got flying chunks of glass flying everywhere from exploding xenon tubes. Alright, here we go. First of all, we're going to start the recording process on here. And we're going to blow that rig up. There we go. We got our first light up. Now we got to start this up again. What the heck? Didn't go off all the way. Oh, it shattered the tube. Oh, interesting. Look at that. Here, let me get that up close. I shattered the tube. So that tube exploded on the first shot. But it didn't explode in the way you may think it may have exploded. First, let me discharge my capacitor bank, so then I can show you. So if you look right here, okay, let me take this out real quick. The tube itself exploded. It shattered all the glass inside it. So the entire tube, which is made of quartz, got shattered. That's pretty cool. It's crazy how much power was unleashed. Let's see if we can take a quick look at that on the recording. Yeah, that's pretty scary stuff. Here we go. Okay, here we go. This is when I start to make it blow. It's a long video. Oh, there we go. Okay, so next frame is what happens. Completely whited out. Next frame, it's glowing red hot. Next frame, this is slight glow. Next frame. Frame after that, it's gone. That's pretty cool. Well, it seems I've exhausted all my resources of small tubes. You know what that means? It means time for the big tubes. This tube can handle all the power that is sent through it. This tube has no problem handling power. This tube is built for power. So we'll connect it up. It's already... This side goes here, I think. This side connects to here. And then this side touches the middle bit of there. Alright, we're going to get this tube ready to launch. This tube, I think, can do it. Then we're going to go for the giant tube. Now, just warning you guys, I've already tried the giant tube with this setup right here, and the giant tube doesn't go off. Now, the reason the giant tube doesn't go off is because the small xenon is because there's a large distance in between the two electrodes. So much that even when you ionize all the gas inside, it doesn't flow. Because these ones are small enough that when you ionize the gas, all the current can flow through. So we've got to build a voltage power supply that's twice as powerful as this one. We'll do that in a way that I'll explain in a second. But anyway, let's see if we can crack this puppy. Let me just make sure I got it all connected. Properly. There we go. That xenon tube is hooked up. And turn this on. I'll get this one on high-speed camera too. Okay, I got the high-speed camera ready. Ready to go, 240 frames per second. Let's launch this puppy off. What do you say, y'all? Alright. Here we go. See? Handles it like a pro. You just see that? The big tube handles this thing perfectly. Let's take a look at the high-speed camera. Okay. Oh, there we go. Let's go back a few frames. Back a lot of frames. Why is this going so slow? How you guys do it on the stream? Oh, that's cool. Look at that. Okay, frame by frame. Got the first frame. Next frame is whited out. Third frame is whited out. Check that out. That is a cool picture right there. Completely bright camera. And the light is still lit. What? Trash. Alright. Okay, we're going to see if we can take this in a slightly higher quality. We're going to try it one more time. See, I like doing things like this. We're going to set high-speed video to HD. It should still give us relatively high quality. The tube is a little bit warm, but not bad. Okay, someone mentioned close the iris a little bit. We can do that. Oh, actually, no, when it's in high-speed mode, you're not allowed to. Trash. When it's in creative video mode, I can do that. Ha! You're spouting fake news right there, Fanatical. Tesla was not a hack. Edison was the one who stole ideas from Tesla. Okay, we're hooking up this camera again for some more quality video. Alright, we're gonna get some more slow-mo. So let's fire up this thing again. Trust me, this is gonna be the last launch of this little Xenon tube. And then we're gonna go to the big Xenon tube and try to light that one off. As you can see, I have the camera already. We're just gonna wait a little longer for it to charge up. If this thing explodes, that will be kinda cool and kinda not cool. So, as you can see over there, it's almost charged up. Not charged yet, though. We want it to be in the red. Alright. It looks like it's charged to me. Well, here we go, guys. Are you ready? Count me down in the comments. 3, 2, 1, go. That was quick. That was quick indeed. See, this tube works a lot better. I love this tube. Let's look at the slow motion video. I did it slightly higher quality. Oh, wait. Go back a few frames. More frames. Oh, that's cool. Look at that. Okay, I'm gonna have to upload all these videos. That picture is so cool right there. Let's see if we can capture it. Yes. Yes. I'll have to upload all these videos. So let's watch that in normal motion. Pretty cool. Alright, we're going to be done for a while with this tube. We're going to see if we can work on getting the big tube to work, because it doesn't work typically. Yeah, slow motion compilation from today's live stream. Okay, so we're going to turn off the camera for now. Scoot it away. Okay, something smells like it's burning, to be honest, right now. I don't know what it is, but it smells burning. That's never a good sign. So this tube is fine. I mean, this tube can handle a lot. This tube is like... This thing's a trooper. I got this thing at Radio Shack like 5 years ago. This tube can handle all kinds of stuff. So I'm not too worried about there. This tube, I have zero worries about this. Now, I got this tube for like $1 or less at a place. And it's got a box of all kinds of cool, crazy stuff. So this tube was relatively cheap. And so, as you can see, you've got these two pins, and these are the two things. And this pin right here is the electrode ionizer pin thing. And so, if we connect this up, we can... how do I do that? Connect it up here. And hopefully we can get this thing to light up. But I'm going to show you, I guarantee you right now, this tube will not light up under current circumstances. So, here, I'll show you this charged up, and I'll show you how this doesn't work. So we're going to have to double the voltage across this. I had the leads right on the points. What do you mean? You mean right on the pins? I have a 12-pin dip socket for this, but I'm not going to use it. Alright, see? Ready, guys? Here we go. See? As you can see, that does not discharge the tube whatsoever. So we're going to have to double the voltage. So you should try swapping them, and theoretically that won't work, because when you swap them, I mean, this tube is the same both ways. So we're just going to discharge this. You guys are going to get scared here. Yeah, just discharge that thing. Safety first. And now we're going to try and build a little thing to get this tube more powerful. Hope I didn't screw anything up inside. I really hope... No, there's no diode in here. Here, let me show you something interesting. So, if I connect this, this proves that this tube still has Xenon inside it. So just in case you're wondering. So, right now, if I turn it on, see, you can see that the low air pressure allows this whole tube to light up. It glows in the plasma. So anyway, that shows that this tube does indeed work, but that we need to get a higher voltage across these two pins. So we're going to get a higher voltage by using capacitors. Hooray for capacitors. So we got these capacitors right here. And I'll just trim off the things that we don't need. Like this. This is actually from a coil gun project that I made for a previous video with there. And then we're going to use these capacitors and put them in series with this rig. So this is going to be a little bit of a tricky setup because I'm going to be working with very high voltages. So don't do this at home, kids. This is going to be a very tricky setup to get this to work. So I'm going to scoot this back. We're going to scoot this aside. Now, first of all, what we're going to need to do is we're going to need to use this capacitor bank. We're going to have to charge up this small capacitor bank and the big capacitor bank in parallel, and then we'll change them to series for our final act. So I'm going to switch this over here because this is positive. That goes to the positive rail of this capacitor bank. This is going to go to the negative rail of this capacitor bank. And notice how I'm using insulated leads. Very insulated. You don't want to use non-insulated leads, otherwise you're setting yourself up for failure. Oh, ow. Not good. Okay, you know what? I'm going to put some of these things on the ends right here. Just to serve as little kind of tap points for this to hook onto. Alright, we're going to charge this up together. So we're charging up this capacitor bank and this capacitor bank together in parallel. And so after this is in parallel, then we'll switch them around to series and we'll have to wire up the entire light bulb to this thing. This is where the tricky stuff comes in. After this is fully charged, we should theoretically be doubling the voltage from the capacitor. So we got these two capacitors plus a whole plethora of more capacitors inside there. That's why this is taking slightly longer to charge up than normal. It's merely because it just is. Now let me see if I can look down here and find some nice insulated leads to connect to. Oh yeah, this is charged alright. So I want to be safe here, kind of. I mean, I typically don't care that much about safety, but I guess safety is kind of important. So I'm trying to find some insulated leads here. Oh, here's some good insulated leads right here. See, this is what I like to see. These ones will work good. Now, to any of you who want to do this at home, probably shouldn't. I mean, I'm not going to openly discourage it that much because this stuff is fun to build, but I'm just kind of forced to say don't do this at home. Don't try this at home, kids. So, this is charged. Now here comes the tedious part. Yeah, I know. Alright, so we're going to have to disconnect these. Now, keep in mind both of these capacitor banks are charged to a lethal voltage and a lethal current. So we're going to connect this up to here. This up to one side of the xenon tube. And this up to another side of the xenon tube. And so then we can very carefully disconnect this lead. And this is positive, so we'll connect it up here. Very safely. Without it jumping everywhere. Without it flying everywhere and touching things. Oh, that doesn't look good to me. Okay, this is not safe. There we go. That sort of looks good. Alright, so now we gotta, before this capacitor bank discharges all its charge, take negative to go to positive. Without it falling. Okay, so we have this in series, I think that's all. And I just gotta connect this up here. There we go. This tube now has... the tube now has about 800 volts across it, because these caps are in series now. So I'm going to turn this on and see if we can trigger the xenon light bulb to flash. No! This is trash. It's not working. Absolute trash. What is the deal here? Everything looks good. Negative to positive, negative. Here, positive over there. This tube just doesn't want to fire off. I just smell ozone. That's all I smell. Yeah, we need more power, but I don't have... Yeah, the 30 kilovolt supply is the trigger, and this thing is to do it. Now, we know if this actually worked a little bit, because this needle would drop a bit. We have a ton of capacitors in series, and it's still not working. How much voltage do they want us to put through this thing to work? Gosh. Let me try that one more time. Nope, just ozone. This is trash. Well, you know what this means? It means I have to discharge all the capacitors before we can work more on this. Wow, how much power do they want us to put through this thing? Oh gosh. Well, let's discharge these capacitors. Ready for a big boom? Boom number 1. And boom number 2 will come in a second. Oh, I just charged the capacitors. Congratulations. Interesting. Are these capacitors still charged now? It's anyone's guess, but I think they may have just been charged. Nope, I think I just... Okay. Look up a formal circuit. Here, well, the issue is, take a look at this tube for me. So this is the tube right here. And if you look at this, there's no data sheets. So if someone on the internet, I know I've got 25 people watching. Here's what you can do to help me right now. So look up this tube or use your internet skills to find a tube like this on the internet. This may have been a tube that sits on top of a transmitting tower to warn the airplanes of something coming, or I'm not sure what this could be from, but see if you can look up the tube and look up the different voltage specs for it. I'm going to keep entertaining the rest of the audience But can you guys see if you can find something on here to see if we can make this tube light up? Because even before this video, I've tried to do this a lot. And this tube may need thousands of volts across it to conduct. I mean, I have microwave capacitors we could use. We could do that. I mean, I've got microwave capacitors, but it's 5:38. I've got time. I still want to make a few Tanner Tech videos today to save up for the future. I'm going to the beach tomorrow. I'm going to make some Tanner Tech videos for y'all. Yeah, I guess you're right. So the U one... So the other one we saw, the tiny one that exploded, that one only... We ran 400 volts through that one. And this one, it couldn't handle the 400 volts. And then this one exploded because it couldn't handle 400 volts. The U one did fine with 400 volts. It just took it like a champ. Just flashed normally. Probably what that one's rated for. And then this one, it can't even handle 400 volts. It couldn't even make it. Alright, thanks, Peter Banana. Here's the tube. We will move around these capacitors. I have a feeling these capacitors aren't going to cut it for what we want to do. Well, okay, so the issue we're having here, if people don't understand, is, yeah, you have to have a certain voltage to keep the gas ionized. So the 35,000 volts is for the initial ionization of the gas inside. And so the gas inside is ionized, but even though it was ionized, it still had a high enough forward voltage. Because tubes have a forward voltage that they need to have in order for the electricity to have a high enough current to flow through the entire tube. So even with the gas ionized, 400 volts wasn't high enough of a forward voltage to push through this tube. It was a high enough forward voltage for this small, like 1-inch tube. And it was high enough forward voltage for this tube, which is probably from anode to anode maybe 1.5 inches. Anode to cathode 1.5 inches. This one from anode to cathode, I would say each individual spiral probably has a circumference of maybe 1.5 inches too. And so then you got 1, 2, 3, 4, 5, 6. That's 6 times 1.5. That's a lot of circumference right there. So, I don't know. Maybe I'll have to get higher voltage. I mean, I ran 800 volts through this one. When I had the capacitors in parallel, see what I did is I took this capacitor bank plus that smaller capacitor bank, because this capacitor bank has a charger inside it too. So I had a capacitor bank that I charged in parallel, and this is the same principle that a voltage doubler works on. And these capacitors were charged together in parallel, and so they were both 400 volts. And then I moved this capacitor around right here, and so we had positive, negative, positive, negative. Sorry about that wonky symbol. But anyway, now we have 2 caps in series, and each of these are 400 volts charged in parallel. So now we got a total of 800 volts. So I tried 800 volts through this tube, and 800 volts did not cut it either. So this, I have a feeling we've got to get some here. Yeah, you got an idea there. So we'll fly over here. So right here I have my microwave capacitor box right on top of my clarinet. Okay, here we go. You know, at MIT they had a giant capacitor there. I wish I could use that. So you got, each of these is 2200 volts. See if I have any microwave capacitors. I may have used all my microwave capacitors, to be honest. Each of these things is like 440 volts. Here we go. We got 3 microwave capacitors. That should handle it. Now I gotta get a microwave transformer. Yep. I'm hoping that with these 3 capacitors and charging it with a microwave transformer, we should have enough power, theoretically, to launch this rig into outer space. Just joking. scoot my camera out of the way. Don't want this to be dealt with. Whoa, 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 there's a lot. 700 volts maximum? I think I'm going to need a capacitor to charge. You guys think 2,000 volts is too much? Oh, I just realized something. No data online. Wait, hold up. Oh, I just realized these stupid capacitors have a 10 mega ohm internal resistor, so these aren't going to work. Dang. Alright, that's not going to work. Never mind. I thought these microwave... Now, we need like 1,000 volts to drive this. We need a 1,000 volt capacitor bank to drive this tube. I don't have a 1,000 volt capacitor bank. And these stupid microwave capacitors have a dumb resistor inside, and the resistor is going to make a discharge in like 2 seconds. Or, here's an idea. This may blow up the tube, but if we took a microwave transformer and we hooked it up to this thing and just straight up pushed power into this, we could get this tube to light up for a good portion of time. That could overheat it though, theoretically. I'm going to have to do more research into this. Yeah, because I don't want to kill this tube, because this is a really cool looking tube. This looks like something that, you know how you see on top of those radio towers or on top of buildings, how they have that super bright light that flashes to warn the planes not to crash into them? This tube looks like something you would climb up onto the top of this tower and plug it in to the top, and then have this tube broadcast and make sure no planes hit it. But I really don't want to mess this up, because, to be honest, that wouldn't be very cool. You guys want me to do anything more before I sign off for the night on the live stream? Put it in the comments. You got a little bit of time. Any more things you would like me to do before I sign off for the rest of the night on the live stream? Any more things? Comment below. What? Oh, okay, my phone is getting really hot. Annoy the dog? The dog isn't in here right now. Use air as a flash lamp? No. Put the tube on the Tesla coil. That's a good idea, but the Tesla coil takes a long time to warm up. You know what? Just for old time's sake, I'll blow up a capacitor. One more second, guys. I'm going to blow up a capacitor. I think I have a capacitor in here that is fit for blowing. Hold up a sec. The fan is working amazingly. Let's see if I have a capacitor that we can blow up over here. You've always got to have a capacitor blowing up. It's never a video without a cap. This capacitor should do fine. Okay, let me fire up the fan. Positive goes over here. Negative goes right here. Ah. Okay, I got the fan working. Let me go and put out the vent. You see, the issue here is the dog can't get out with my vent out here. Look, the vent just blows away all the stuff on the bottom. That's cool. Blow up a capacitor in water, you say? That sounds like a good idea to me. Let me go get some water. Alright, I'm back, everybody. I got some water. We're gonna video this with a high-speed camera. This ought to be cool. And I got the protection fan for any protection in case anything happens. Alright, here you go. I'll post a video of this too. Well, first of all, let me set my camera. Sorry about all this time I'm taking, dudes. Oh, no. I touched something on the camera that I messed it up. Okay. Messes. I'm gonna put the capacitor inside. No, this water isn't glass, actually. It's something else. So this shouldn't be as bad. But let's hope this looks cool. This will be a cool capacitor explosion underwater. There we go. We got the capacitor underwater. This should be cool. I got the slow motion camera on it. Alright, guys. Ready for this thing? Get ready for the spray. Should I put something over it so it doesn't spray? I'll put this Ziploc bag over it. Alright, here we go. Ooh, that's cool. It's just making bubbles. That wasn't as cool. We need to get one without any venting caps. It just sprayed a little bit of water. At least it kept it cool. Alright, now I have to get some non-cloudy water, because this water is full of seepage now. I will be back. Just a second, guys. Okay, we got some new water. That really clouded up the old water. And now we're going to try to get another capacitor. I've got a bunch of capacitors here. I think I have a capacitor in my trash. There's a lot of trash in the trash, but I think there's a capacitor in here too. Oh yeah, here we go. Here's this. These capacitors are non-venting, and these things will blow like you never would expect. So we're going to put this capacitor in. Negative to positive. Like always. Okay, just gotta line this thing up real quick. Let me use this. Alright, that looks good to me. Okay, guys. Alright, something weird is happening here. Here, hold up a second. I'm gonna set this on top. There we go. Oh, okay. I'm sorry for the interruption. It'll be short. Okay, here we go. 3, 2, 1, go. It's bubbling. Okay, we're not getting significant current flow for this thing to blow up. Dang it. We just hydrolyzed some water, that's about all. Can I blow it out of the water? Nothing. This capacitor is stupid. Okay, we need to get one good explosion on here. One good explosion. That's all I want. This capacitor looks good for exploding. No, it doesn't. I have tons of capacitors in here to do it. They're all high voltage though. 50 volts, you can't blow up a 50 volt capacitor very easily. And all these capacitors have the dumb lines on them. There we go. This capacitor should work. Theoretically. Let's try this out, guys. One more capacitor. Here we go. They don't blow. They're just bubbling. And we lost all the power. Gosh dang it. Well, that was not interesting. Alright guys, thanks so much for watching. Stay tuned for next time. I'll put a highlight reel of all the cool slow-mo stuff that happened, so stay tuned for that in like an hour. Bye!